continue in 4.5 with graphing our rational functions using the 5 steps. We're just going to write the steps down. So number 1 was finding our vertical asymptotes. And I know we just did a quick review, but where were the vertical asymptotes going to be? How do we find that vertical asymptote? What x we can't have?
On the bottom.
It's the bottom, right? So we're just going to set x plus 2 equal to 0. So x equals negative 2 is our vertical asymptote. And I'm kind of going horizontal just so I make sure I have enough room. Is that okay? Let's go ahead and sketch that. So we're going to go over to negative 2, go up and down with a dashed line as much as you can. There he is. So I know this question didn't ask it, but on the test or on the homework, if they ask you for your domain, what would your domain be, guys? Everything but that. So how would we say it? We'd start where?
The union.
Yep, so we're going to start negative infinity to negative 2, union, negative 2 to infinity. All right, so they are just complements of each other. They just, one, if you have one, you have the other, really. Okay, number 2. It's either a horizontal asymptote or an oblique, but what do you notice about the degrees of our polynomial?
They're the same.
They're the same, so we're going to have a horizontal asymptote. Do you remember how to find the degree when they are the same? Think in your mind, oh, they're growing at the same rate. So what do we look at if they're growing at the same rate?
The things in front of them.
Yeah, the leading coefficients, which, what are the hidden leading coefficients for each? 1. So what's 1 over 1? 1. So our horizontal asymptote is just y equals 1. Let's go ahead and sketch that. So I'm going to go up to a y value 1 and then just sketch it across horizontally. And again, it's hard to make them invisible. Okay, so we have like our quadrants kind of formed now. Number 3, guys, is finding the zeros of your function. The zeros of your function are when your function equals 0, but the only way a fraction can equal 0 is if the top equals 0. So we're just going to set, so these are the zeros. I'll write that. So we'll just have x minus 3 equals 0. So what is that value? X must be 3. Is that okay? And so then what's our ordered pair going to be? 3, 0. So the only way you can find zeros of a function is to set the numerator equal to 0 and solve. So x minus 3 equals 0. Move the 3 over, you get x equals 3. But an interceptor 0 is usually put into ordered pair. Let's go ahead and graph that one. That's 3, 0. So here's the origin, 1, 2, 3. I'm putting them right there. So we already have an idea that this guy's going to kind of be in this little quadrant down here.
That makes me so confused.
What?
Just like with all the lines, I'm like, where's
Oh, I know. It's hard because I don't feel like the axes are very dark. So it's hard to go back to the origin. This is the origin.
It literally makes me feel like I'm...
La la land. Looking, seeing double.
Yeah.
Number 4, guys, is the y-intercept. The y-intercept is where you cross the y-axis, which means x is 0. So we're finding f of 0. So put 0 wherever you see x. What will happen? That will be negative 3/2 over 2. So what is our y-intercept as an ordered pair? 0, negative 3/2. And if you need to, throw negative 3/2 in your calculator so you have an idea of what number that is, but that's just negative 1.5, okay? So we're going to go to 0, 0, but then we're going to go down 1.5 units. So here's the origin, and we're going to go down 1.5, so here's our y-intercept right there. And we kind of knew that. We knew we were going to kind of be shaping this right here. All right, guys. So step number 5 says find any more random points that you may need. So we have 2 over here. I might pick 1 more for the right side, but I want to pick 3 points that are to the left here. And I'm just going to kind of, let's see, we're at negative 2. So let's pick like negative 3, negative 4, negative 5 and see what's happening. So let's find f of negative 3. How you find that, guys, is putting it in your function. So maybe I'll do it for the first couple, but we obviously don't need to do it for every one. So we'll just put negative 3 up top and then negative 3 at the bottom. All right. So that ends up being -3 minus 3, or -6, over -3 plus 2 is just a -1. What's -6 divided by a -1? +6. So our ordered pair that we're going to graph is -3, +6. And I just did that by hand, but if you want to do it in the calculator, you can. So I'm going to go to the origin. 1, 2, 3, and then I'm going to go up 6. 1, 2, 3, 4, 5, 6. So then again, we kind of have an idea that now that he's going to probably be in this shape. All right, let's do the same thing, but for f of -4. -4 minus 3 over -3 plus 2. Oops, not -4 plus 2, excuse me. Put in -4 for each x value. -4 minus 3 is a -7. And then -4 plus 2 is a -2. A negative divided by a negative is a +7/2. So the point I want to plot is -4, 7/2. Again, though, if you want to put that in your calculator to get an idea of what it is, it's just 3.5. So we're going to go over 4 to the left and up 3.5. So I'm going to go to 0, 0, 1, 2, 3, 4, and then up 3.5, 1, 2, 3, and then a half. So you kind of, again, have an idea of what we're going to do. All right, I'm running out of room, so you're seeing what I'm doing. So I'm just going to say what the answer is, guys. All right, we'll put f of -5. That means I'm going to put -5 into my function. When you do that, guys, you get 8/3. So the point we want to graph is -5, 8/3. 8/3, 8 divided by 3 is 2.6 repeating, so a little bit more than 2.5, okay? So we're going to go to the left 5, 1, 2, 3, 4, 5, up 2 and a little bit more than a half. And you guys, we have enough to sketch the graph. Remember that we're going to kind of go through those points, but then we're going to write along the asymptotes, all right? So try your best to kind of sketch the graph, like go through the points, but go up towards your asymptotes, for this part of the graph at least. On the second part of the graph, to the right of the vertical asymptote, we already have 2 points, but let's just plot one more point. Let's do f of -1, just to be sure. And again, how I would do it is I'd plug it up in here. When you do that, guys, you get a perfectly an even -4. So we're going to graph -1, -4. And he goes where I would think he would go. On a count over 1 and then go down 4. 1, 2, 3, 4. So again, you have this shape of the graph where we're going to go through these 3 points, but then we're going to follow along these vertical asymptotes and these horizontal asymptotes. There, you guys did it. You graphed it without a single graphing calculator, which is it's impressive, I think, when you get done. These 5 points, you don't have to memorize them. So like on the test, I'll say number 1, find your domain and your vertical asymptotes. Number 2, find your horizontal or oblique asymptotes. Number 3, find your zeros. But you need to know what to do or how to find them, but I'll remind you what you need to find. So for extra practice, let's just keep going, all right? So let's just do the same thing for number 6, where we're going to do steps 1 through 5, and then hopefully be able to sketch the graph of our rational function. All right, so number 1 is finding your vertical asymptotes, VA. Your vertical asymptotes are what your x cannot be, so where will we find those? The denominator. So we're going to set x squared minus 9 equal to 0, and we have a little bit more room than I realized. So you can show your work. What would you have to do? You have x squared equals 9, but then how do you undo a square?
Square root.
And what do you put in front of that square root?
Plus or minus.
Right. So what's the square root of 9?
Plus or minus 3.
And perfectly 3, right? So we have 2 vertical asymptotes, x equals -3 and x equals +3. If that makes sense to you guys, go ahead and sketch those on your graph. Try to make them as bold as possible. So I'm going to go over to the left 3, 1, 2, 3. And then I'm going to go to the right 3, 1, 2, 3. There they are. So you'll notice that the vertical asymptotes, they separate our domain into 3 chunks, all right? So the next question is, do we have a horizontal asymptote or an oblique? So how do we find those? What do we have to consider? Do you remember?
Hold on one second. What are we doing?
So we're going to find a horizontal asymptote.
You do the leading coefficient.
The leading, how'd you know?
Because they both have the same power.
Thank you. Okay. So to know whether you have a horizontal or oblique asymptote, we need to look at our powers of our top and bottom. If the bottom power was bigger than the top, that would just be a horizontal axis of y equals 0. But since the powers match, it's going to be these leading coefficients. And what's technically the leading coefficient? -1/1. So y would equal -1. I don't know why I didn't box that up there. All right, so y equals -1. So go to the origin, go down 1, and then sketch right across horizontally.
Wait, how did you get -1?
Our leading coefficient, right? On top, your leading coefficient's a -1, and on bottom, your leading coefficient's a
For some
+1.
reason, I kept thinking it was like the first, like 8.
Yeah. No, so your leading coefficient is the coefficient in front of your highest term polynomial, or term with the highest degree. All right. So then 3 is finding your zeros. So this is a little bit different. Finding your zeros is where does your function equal 0, but the only way a rational can equal 0 is when the top equals 0. So we have 8 minus x squared equals 0, and we have to solve. So what do you guys want to do in order to solve that?
Subtract 8.
Yep, so we'll have -x squared equals -8. Then what's your next move?
Square root.
We can't square root yet because we're not isolated. Divide both sides by what?
-1.
-1. So we have x squared equals 8. Now we can take the square root. I'm going to go off to the side just because I don't want to make it too much vertically. So we have x equals plus or minus the square root of 8. Do you follow me so far?
Yeah.
But then that can reduce, right? What is this, that? That's 2 times 4.
And 2 and 2.
2 and 2. So a 2 comes out, but a 2 stays in. So x equals plus or minus 2 root 2. So we're going to have 2 places where we cross the x-axis. One at positive 2 root 2 and one at negative root 2. 2 root 2. If you put in your calculator, guys, this is approximately plus or minus 2.8. Okay? So I will let you have, like, maybe I'll even bring with me on the test. Like, I don't want you to have your graphing calculator, or maybe I don't care as long as you're doing these steps, because I want you to have a calculator to be able to do stuff like that. Like, I don't know what 2 root 2 is, and I'm supposed to cross the x-axis there. How do I know? I want you to have a calculator so you can put it in. So either I'll let you use your graphing calculator as long as you're following all these steps, or I'll bring scientific calculators in and you can have those to figure out those. All right, so let's go ahead and plot those. So we're going to go to almost positive 3 and almost negative 3. So almost, go back to your origin. I know it's hard to find. 1, 2, 3. So we're actually on the inside of our asymptotes, right? And then we're going to go over 1, 2, negative. So yeah, we're right there on the inside. Because our asymptotes were at 3, correct?
And that's our only ones we have.
Those are the only ones we're going to have. So that means we're probably going to be graphing down here, right? Because if we're up here, we most likely would cross those x-axis. So it kind of gives you a heads up what's going to happen. Number 4 is your y-intercepts, but that always means plug 0 in for x. So we're finding f of 0, which is right up here. 8 minus 0 squared over 0 squared minus 9. The zeros are nothing, correct? So we just have 8 over a -9, which is -8/9. Almost -1, but not quite, right? So our y-intercept as an ordered pair is 0, -8/9. I know I'm writing really small. Okay, so I'm going to go to my origin, but again, I'm glad it's not -1, because what's that -1? The asymptote, so I'm just short of it. Guys, we can go ahead and sketch that part of the graph. What's it going to look like? Like a U just kind of just curving along all those asymptotes. So go ahead and sketch that. So we're going to go through our y-intercept and our 0, and we're going to go up and right along that. And we're going to go through our y-intercept and to our other 0. Is that okay? So then we already kind of have an idea, but let's do number 5 just in case to get a couple points. Let's just do 2 on each side. We'll have an idea. So let's find like f of -4. Again, how do we find that? We just plug it into our function. So I'll go ahead and tell you what it is because I've already done it. If you plug -4 in and square it, 8 minus blah, 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 you get -8/7. So the ordered pair we're going to graph is -4, -8/7. That's just barely over -1, okay? So let's go plot that. We're going to go to our origin, and we're going to go over 4. 1, 2, 3, 4. And we're going to go barely past that asymptote. So we're just right there at -8/7. And that makes sense because we know we're supposed to kind of be closer to the asymptotes. Let's go ahead and pick -5, f of -5. Again, what you do is you just plug it into the top, plug it in the bottom. You'll get -17/16. Still, just barely over -1. So the plot point we're going to plot is -5, -17/16. You're basically just right there, but at -5. Maybe even a little bit closer to the asymptote. So you guys have an idea what we're going to do. We're just going to kind of draw that graph right in there. Shove it into the corner, and then go down our vertical asymptote. We could have done that probably without picking our points because we knew it wasn't going to cross the x-axis anymore. So, all right, let's pick a couple over here. Then let's pick like +4 and +5. And what happens, it's an even function where everything's the same. So when you plug it in and do the same thing with 4 as -4, you still get -8/7. So you're going to plot a +4 8/7. So we're going to go over 4 and just go barely past our horizontal asymptote. And then you guys can guess what f of 5 is.
It's the same.
It's, yep, -17/16. So we'll go to +5, but then graph -17/16. Again, just right there. And so it just kind of goes right in that corner. So again, you guys were able to graph that crazy rational function without a single.
So do you have to do the random point?
I
How
do.
do you know when to stop?
Right. I always like to have at least 2 points in each interval of my domain. So like here, this vertical asymptote had a left side and a right side to my domain. So I picked like 2 points over here and 2 points over here. And then we had 2 vertical asymptotes, so I want 2 points here, 2 points here, and 2 points here, at least. So I wouldn't do more than 2 or 3 in each like interval, okay?
Because there has to be something in each like interval?
Yeah, that's what's nice. Because think about the domain, -infinity to your asymptote, so something's happening in that graph.
Oh, yeah.
You just literally think about these vertical asymptotes being your unions, right? So we know something's happening -infinity to -3, -3 to 3, 3 to infinity. And we just graphed it.
Once we did the first little U thing, if I didn't know, I would have just stopped it there. I didn't know.
Right. Yep. So you want to make sure you're picking. Does that make sense? We don't worry about as much as top and bottom as we worry about left to right.
Okay, that makes sense.
All right. So let's do this last one. He's going to follow the same rules, but there's something different that happens when we get to asking ourselves, is there a horizontal asymptote, yes or no? So let's look at this one. So we have number 1, find your vertical asymptote. Where's your vertical asymptote always located? The denominator. So the denominator can't equal 0. So x plus 1 equals 0, so x equals a -1, right? That's our vertical asymptote. So go ahead over to your graph, go over to -1, and just kind of try to dot that line as best as possible. All right. So number 2, I'm going to be a little slow to write HA because it's really HA or OA. When it comes to finding out whether you have a horizontal asymptote or oblique, it's all about the powers, right? So if the power on top is smaller than the power on the bottom, it's y equals 0. If the powers are the same, it's the leading coefficients. But if the power on top's bigger, it's an oblique asymptote, and we must do long division, okay? It's good practice, though. All right. So we're going to just do x plus 1 here, and then inside here, we're going to have x squared plus 0x plus 0. And I know that looks really weird, but remember, you need to have every place value held from your highest degree down to a constant, right? So since it was just x squared in the numerator, we needed something for the x's, and we needed something for the constants, so there they are. All right, think backwards. What does x need to be multiplied to become an x squared? Another x. So let's just throw another x up there. Once you throw it in your quotient, take them by each part of what you divided by, right? So what's x times x? Good, that's what we wanted, right? And then what's x times 1? Yeah, just 1x. Do you agree? And then what do we have to do? We have to subtract. So let's go ahead. I'm going to just distribute my negative to both parts, all right? So negative and then negative. What always happens with your first two terms, they'll always cancel. And what's 0 minus 1? Negative 1x. Bring down your plus 0. All right. What does x need to be multiplied to become a negative 1x? Negative 1. He already has the x part, right? We just need a negative 1. What's negative 1 times x? Negative 1x. What's negative 1 times 1? Negative 1. And then what we're going to do is subtract. So if we subtract both parts, it actually becomes addition. And then we have this 1. We don't care about the remainder, because remember that technically goes to 0. So what we care about is our oblique asymptote. It's just that line, x minus 1. So y equals x minus 1 is our oblique asymptote. Let's graph it, okay? So we're going to graph him just like we're used to graphing normal lines, except for instead of drawing that straight line, we had to make it dashed, all right? So start with its intercept. Where is its intercept? Right here, negative 1, right? So you go down to negative 1, make a point right there, okay? And then what's our slope? Just 1. So technically we go up 1 over 1, up 1 over 1. So I'm going to plot a couple points in either direction. But then instead of connecting them, I'm dashing it right up that diagonal. You guys just graphed an oblique asymptote. Just go up that diagonal.
I feel so cool.
Isn't that cool? Yes, sir.
Is there a reason for not using synthetic?
No, we probably could do synthetic. I'll talk to you about, I talked to the class on Thursday about why we need to do long division, or know how to do long division, but in finding oblique asymptotes, the degree will always differ by 1. We do have to do long division. In this one, we don't, but sometimes you might have to, so it's safer to just always go with it. What it is with with synthetic division is you can only divide by a 0, okay, of the denominator. So we could divide by negative 1 synthetic division and be fine. But if this was an x cubed and an x squared, it's hard to find zeros, and so it's easier to just do the long division, if that makes sense. So synthetic division only works if you're dividing by a first degree polynomial. Or you have to find the zeros of a second or third degree polynomial. So it gets a little bit more difficult. So when I teach it in this section, I always just do it with long division. That way you don't even have to stop and think, can I or can I not? Just do it with long division and you'll get your answer no matter what. All right, so on this, number 3 is your zeros. But remember, your zeros are only when your numerator equals 0. So x squared equals 0. Well, that's easy to solve. What's that? Just x equals 0. So we don't even have to put the plus or minus there. Our 0 is just the origin, 0, 0. So right there, you kind of already know what's going to happen in that part. We have to be in this little v. So we're going to graph this, probably this little v. We're going to pick a couple points just to make sure, though. All right, number 4 is the y-intercept of your function, and that means just find f of 0. Well, we already kind of know. That's going to be 0 squared over 0 plus 1, but that's just going to be 0. He doesn't help us at all. All right, so we already know what he's going to be. Let's go ahead and sketch him. We don't really need to plot any more points because we know he's going to be in this little chunk of the graph. So that means he's just going to kind of ride along there. So the question is, are we going to be here, here, here? Most likely we're going to be here. You're going to be cat a corner. So let's just find like f of, I don't know, what did I pick? F of negative 2. So I'm plugging negative 2 up into my graph. I'm squaring it and to get 4. And then I put it negative 2 plus 1 is a negative 1. So 4 divided by negative 1 is just negative 4. So I'm going to graph the point negative 2, negative 4. So I'll go over 2, 1, 2, and go down 4, 1, 2, 3. See how he's just going to kind of mimic what we have on the other side?
Cool.
Yay. And so that's what it looks like because we had not seen an oblique asymptote yet, like graphed. We found it, but we haven't seen it graphed. So the one last thing I want to talk about is this whole idea of holes. And I didn't do a very good job of stressing it while we go about, but I mentioned it on Thursday. I'll go back. You guys just keep your notes right there. Right here, It says a vertical asymptote for a function where p and x and q and x are polynomials with no common factors, meaning the top does not cancel out with the bottom. Those would be 4. So like everything we've seen so far, the top has not canceled out with the bottom. So the bottom where it equaled 0 is always where our vertical asymptotes are. But sometimes when you factor the top and bottom, they do actually cancel out. So there's this idea of holes, okay? So we're going to just star this part right here. I said, if the numerator and the denominator both share a factor, then there's a hole at the 0 of the common factor, okay? Meaning, if you can cancel it out, it's not really a vertical asymptote, but you do have to say x can't be that, because at one point it made the denominator 0. So let's look at 8 here, okay? So it says, find the vertical asymptotes, horizontal, and identify the location of any holes. So what I'm going to do first, before I even label number 1, vertical asymptote, I'm going to rewrite this function, but I'm going to put it in factored form, okay? So purpose is just to save time because we're getting close to our 30 minutes. Guys, how would we find this in factored form? Factors of -2 that add up to -1, -2, and +1. So this factors to x minus 2, x plus 1. Is that okay? So what factor do they have in common? X minus 2. So we could really actually rewrite this rational function like this. All right? So the original looked like it had 2 points that x couldn't be, but in the end one, there's only 1. And so this is always your vertical asymptote. Your vertical asymptote is always what remains after you cancel. So the x plus 1 is our vertical asymptote, but this little guy right here is considered a hole. So you literally would just draw a hole right there in the graph. So number 1, it asks us for a vertical asymptote. After you factor and you have a common factor, it's the remaining denominator. So x plus 1 equals 0 will get us our vertical asymptote. So our vertical asymptote is x equals -1. See that over my head? Number 2, it wants to know your horizontal or oblique. What do you notice about the powers or the degrees of this polynomial? 1 on top, or 1 on the bottom is bigger, right? So what's that mean our horizontal asymptote is going to go to? Y equals 0. Remember, there's no thought process there. It's just, hey, that denominator on the bottom is going to grow quicker. Last but not least, 3, a hole. And when it wants your location, it wants to know the x and the y. You're like, well, how do I plug it in to find my y? Well, you grab it from here. So our hole's happening at 2. But then you just plug it into the reduced form to get the y value, okay? So we have a hole at x equals 2. So we'll find g of 2 in the reduced form. 1 over 2 plus 1 is just 1/3. Does that look right?
Why is it 2 not -2?
Because remember you said x minus 2 equal to 0 and you would solve, right? Oh. -2 would make that -4. That's fine. But a +2 minus 2 would make it 0. So there's a hole at x equals 2 and the y value would be 1/3. So you would graph, I'll make a note, you would graph 1 over x plus 1 with a hole at 2 1/3. Okay, so it really would just have one vertical asymptote. You'd have one vertical asymptote at -1 up there, and then you'd graph it like normal, like you know how we connect the dots, but then you literally would have like a hole like this as you pass through 2 1/3 or whatever your graph's doing, okay? So I wanted you just to physically see what a hole would look like. They don't show up very often. You won't see it on the test, but I just want to point it out there that that is something that could happen where you have this whole function that looks like it's continuous, but really tiny itty bitty point right there at 2 1/3 is actually a hole.